Hi students, we are going to solve the problem number 9. A gas made of a mixture of 2 moles of oxygen and 4 moles of argon at a temperature T. Calculate the energy of the gas in terms of RT. Neglect the vibrational modes. So we have studied that when heat is given to any system of a gas, its total kinetic energy is equal to the translational kinetic energy plus rotational kinetic energy plus vibrational. Here vibrational modes we will forget. Okay, only we are going to consider which two. The average kinetic energy, okay, due to the translatory motion and due to the rotational motion. So how many degrees of freedom each gas will have, let us find out first. I will consider first oxygen gas. Okay, so oxygen gas is diatomic. So it is diatomic. For a diatomic gas, the degrees of freedom is 3 due to translatory plus 2 due to rotational. So totally 5 at normal temperature. At normal temperature it is having 5 degrees of freedom. And how many moles of oxygen are given here is 2 moles. So the number of moles N is equal to 2 I will take. Okay, 2. Similarly, the other side 4 moles of argon gas is given. Argon is monoatomic. Okay, argon gas is monoatomic. So this is a monatomic gas. And it is having only translatory degrees of freedom. Therefore, F is equal to 3 only. Understand? It does not have any rotational degrees of freedom. Okay, now the number of moles, 4 moles. So here number of moles is equal to what? 4. Now average kinetic energy, okay, average kinetic energy per molecule, first I will write per molecule. For one molecule, okay, it is having 5 degrees of freedom. Therefore, this is 5 by 2 K into T. This is for only one molecule. Similarly, kinetic energy, average kinetic energy per mole for 1 mole. For 1 mole, this is equal to 5 by 2 R into T. Gas constant R into T. This is for 1 mole. 1 mole of what? Oxygen gas. Like that, how many number of moles are there? 2 moles. Is it not? 2 moles. So the average kinetic energy for 2 moles of oxygen, it is 2 into 5 by 2 RT. So how much it is? 2 and 2 get cancelled. Remaining is 5 RT. This is the average kinetic energy for 2 moles of oxygen. First of all, have you understood this step? Okay. Now similarly, we will do it for argon gas. Very simple it is. So here also what? Kinetic energy, average kinetic energy per molecule. So per molecule is now equal to 3 times half kT. So this is 3 by 2 K into T, because it is having 3 degrees of freedom. And hence kinetic energy average value, okay, for 1 mole. For 1 mole, it is equal to 3 by 2 R into T. Is it not? Similarly, average kinetic energy, okay, average kinetic energy for number of moles, 4. So for 4 moles, already we have written for 1 mole. Therefore, for 4 moles, it is 4 into 3 by 2 RT. So that this is 4 by 2 is 2. So this is 2 into 3 RT. So that this is equal to 6 RT. I hope you must have understood this step also. Understand? Separately if you do means there will be no confusion at all. So keep it always in your memory that the average kinetic energy per degree of freedom is half kT for 1 degree of freedom. Therefore, for 5 degrees of freedom, it will be 5 by 2 kT. For 3 degrees of freedom, it will be 3 by 2 kT for one molecule. Then for 1 mole, it is into RT. Therefore, for n moles, you have to multiply by m. Understand? So, here I have calculated the kinetic energy for 2 moles of oxygen, that is 5 RT. And here for argon, the average kinetic energy for 4 moles is how much? 6 RT. Therefore, what should be the total? Therefore, total energy must be equal to, understand? Total energy must be equal to 5 RT plus 6 RT. And this is equal to how much? 6 plus 5 is 11 RT. So they have asked to calculate the energy of the gas in terms of RT. In terms of RT, it is how much? 11 RT. Is it easy? I hope you must have understood well. Fine.